Okay. Can I write that down? Yes, thank you. Thank you for your introduction. My name is Keiji Nagatani from the University of Tokyo. Too dark, I think. Okay, I'd like to speak about the toward enhanced productivity in construction sites and exploring cooperative and competitive R&D to enable automated earthworks. So at the beginning, I like to show the background of my research. At the beginning, I was working on inside small mobile robots. And now, after the March 11th, you know, the March 11th, the big earthquake happens in Japan. And then almost all my research turns to from the such kind of small robot to the bigger robot, to apply the robot technology into the disaster environment or construction sites. That's why I'm today, I speak in here. And in 2011, I put the robot into the nuclear reactor building to observe what kind of happens inside of that. So after that, I found that we need to focus on the real site for the robotic technology. So now I'm working on 3 projects. One is I belong to a construction lab, and I am working on autonomous construction. And then I started Moonshot project from the 2020. And recently, I started SIP project, and I would like to talk about this project in this workshop. This is called SIP project, and I'm working on sub-project A, Smart Infrastructure Management System. And we call this project the ICAS, because it's an innovative construction and surveillance project. So in this project, we have several topics. And one of it is autonomous earthworks for total optimization of construction process. This is an automated construction in the earthworks. So almost all of you already know about the background of our situation. In the construction industry, the automated construction technology is an urgent issue to solve the problem of labor shortages due to an aging and shrinking population in Japan, actually in the world. And one solution is, let's make automated earthworks. And the Japanese government also push such kind of technologies and give the research budget to many people. And we also conducted one research in the Moonshot project that I mentioned in the previous slide. And this is automated earthworks. And we focused on the collaborative work between the several individual construction machines. So each robot worked together. I think that it seems like it works fine. However, the one guy, general contractor in charge of the construction site, tweeted that the current automated construction technology can make motion of construction machines, but it cannot do job. So I think this is only the part that I want to speak in here. The problem is that a typical automated construction demo, the dandori is conducted by human in advance. The dandori is a Japanese word, so not everybody know about this word, but it's a bit very difficult to translation from the Dandri into the English. So let's say that the scheduling, arrangement, or preparation. But the process of ensuring efficient progress of construction by combining elements such as planning, material procurement, personnel allocation, safety measures, schedule measurement, management, and schedule management. So everything is Dandri. And the construction guy said that Dandri occupies almost 80% of the earthwork. However, when we demo using construction machines, only about the 20% of the whole earthwork job is shown. So first of all, I think we need to evaluate automated earthwork system. So then the autonomous level in construction should be required to proceed autonomous construction, like autonomous automobile. So there already was an autonomous level in construction presented in ICRA 2020, and the Morikawa-san and Otsuki-san already presented. This is a level of the construction from 0 to 5, and this is a 0, 1, 2. And the level concept of automation of autonomous construction, this is a very small characters. So I like to skip the 2 slides, but I like to focus on this. So the interesting part of this paper, it says that there is a level 2.9, not 3. So the level 2.9 is automation of each machine. Detailed motion instructions are required for machine to perform its task. So in this case, the general conductor guy said, but it cannot do job. So level 3, automation of construction system. The construction plan is generated by operators with system assist. So it means that not human being, but the system generates the plan of the whole earthworks. And in this level, Kajima Corporation made a quad axle. So somebody may know about the quad axle. So the system works in real site and it's a spreading and compaction. This marks the third dam construction site plus tunnel. Then I can say that it's almost a front runner of automated construction in the world. The system generates motion of machines. So, however, the target is to construct CSG. CSG means cemented sand and grave dam. It's a very special, and the technology is not applied to general earthwork practice directly. The systemization of construction procedures of general earthwork is insufficient. So, once we reach to the level 4, automation of construction system, and the construction plan is generated by the system and for the general earthworks. So there is a big gap between the level 3 and 4. So our project we are now starting is to do to compensate between the level number 3 and the number 4, the big gap. So then what is the general earthwork? It's not the dam construction, but the general earthwork is the very standard excavation, loading, transport, release, spreading, and compaction. And it can be applied to many small civil construction sites. That is why we are focusing on this. And to achieve fully automated construction, our ICAS project aims to systematize tasks to enable general earthwork. So the first part, I would like to say that the systemization of construction system with dandori is very important. And I like to people know about the Japanese dandori. It's like a omotenashi. No, but this is very important word in Japan. But then I will speak. The next part is the collaborative part. So in Japan, or maybe in the world, conventional research and development framework is it makes by the several groups, and each group has some kind of NDA, and it is very difficult to communicate between each group. Then we like to make such kind of the very easy research and development part by using a common communication rule. The common communication rule is to control the robot or construction machines with the same signals. And now we are focusing on the working, particularly the PWRI, the Public Works Research Institute is now making a platform for earthwork with robotics and autonomy. And it is called Opera. And Opera consists of hardware, simulator, communication rules, and middleware. And using this framework, we can use visualize motion with a ROS2 system. And then making using a simulator, we can confirm whether this system works or not. And finally, with the same program code, we can verify the actual motion in the real environment. So you can see the three windows. And then we are now working on using this kind of the system into the excavators, dump trucks, and also bulldozers and compaction machines. And you can download it. This is an open software, so you can download this Opera system with GitHub. Then and you can test such kind of system in your desktop machine. So now this is an overview of the ICRA project, and I cannot speak the many good results because the project just began. But I like to share our idea, and this is an overview of our project, and it includes a robotic side and the civil engineering side. And the communication is very important, I believe. So I like to summarize this talk. The problem is the current automated construction technology can make motion of construction machines, but it cannot do the job. So the systematization of construction system with dandori is important, and we will do the job research and development based on this concept. And the second is current research and development in earthwork is conducted by the development group consisting of major general contractor and related companies. Then setting up the cooperative area is very important. And the SIP ICAS project starts 2023, and we will make a website, and you can see what is happening. So that's all. This is the introduction to my project. So thank you very much for your listening. Thank you. Yep.
Hi, Marko Sosinski, Tadano Limited. You mentioned the Dandori as a principle for cooperation and for automation framework. In this case, this relates to the earthworks themselves. Do you plan any interaction with the further stages of construction? So for civil engineering, it's laying the cement works. For building construction, it's laying the foundation, then building, following up with the building.
Okay, you are talking about not the civil engineering, but the building construction. No?
Or both, but
both.
Initially, let's go with the actual construction. So does the framework intend to provide some link with the further stages of construction?
So I don't catch completely your question. So you're talking about Dandori is a link between the...
For earthworks, we have all the scheduling, planning, etc. But during the earthworks, usually we already start accumulating cache of materials, cache of subcomponents for further stages. So as the time progresses, the area available for construction machinery is shrinking rapidly as soon as they finished compacting the soil. If they prepared hardened surfaces, well, for cranes to move in, the bulldozers have to move out completely. So would that be included in the framework?
So the name of the Dandori includes everything. So that's a problem for communication between me and the construction guys. But our idea is in our narrow meaning of Dandori, we don't think about going back to the scheduling. But first of all, we need to think about when we do something job, what we need to prepare before they're doing a job. That part is a Dandori. It includes a time scheduling and management of the soil or something like that. However, once something happens, very small change or small modification, the robot or construction machine should apply in the local area. However, once the big change happens, we should reschedule or replanning everything. In this case, we need to start at the beginning. So in this case, we need to do everything so that the Dandori is not exist in that case.
Yep, okay? Thank you very much. Do we have time for another question? I'll come back to
you. Thank you so much for interesting talk. And it's very interesting to, hear Dandori, because some of the Korean construction workers also using Dandori from Japanese. I wonder, this Dandori is basically comes from human experience.
Yeah.
Construction workers' experience. Yeah. So once construction worker look at the, construction site, they can tell how many trucks we need, how many excavator we need, and where to locate, and how to dump. Those are all related to the initial configuration and human experience. So I wonder how you tackle this problem, because this is really challenging and difficult issue. Maybe, if we can get some database or database human experience. I wonder if there is such a way to database human experience and using, foundation model or recent, AI technology, then probably there is some way to provide a solution for this. So I wonder, what do you think about this approach?
Yeah, very, very good question. Because the Dandori is based on the experience. And the typical workers in the construction site don't speak very much. And I asked something, and they replied very, very small words with no meaning. So that is a problem for us. But once we need to realize the level number 4 is full construction with based on the system. The system requires the situation or some experience inside of the system, so that we need to disclose, or we need to think about how to combine the several experience, or we just create a other way from the not based on the human experience, but the other machinery method. So, but anyway, this is a